Hello everyone. In this video we're going to talk about basic definitions and terminologies regarding probability, and specifically we're going to talk about these two: random experiment and sample space. Let's start with random experiment. Random experiment is an experiment that can result in different outcomes when repeated in the same exact manner. Well, basically what it means is each time that you repeat the experiment, the outcome of that experiment randomly changes. And the number of outcomes that can happen can be finite, but they change randomly. And you can think of examples that are listed here. Flipping a coin is a random experiment. Flipping a coin twice is a different random experiment. We'll talk about that. Throwing a die, selecting two marbles from a container containing one red, one blue, and one green marble, and also spin a roulette wheel, which we'll use this example quite a lot in this module. Well, you might think, what is the difference between flipping a coin and flipping a coin twice? They seem to be the same random experiment. They have kind of the same outcomes. Well, there are different random experiments for a reason, and that is sample space. Their sample spaces are different. What is a sample space? Well, sample space is a set of all possible outcomes of a random experiment. When you think about flipping a coin, the sample space of that experiment is whether you obtain heads or tails. That is the sample space of flipping a coin once. At this point, I want you to think about what is a sample space of flipping a coin twice, which makes it a different random experiment than flipping a coin once. The sample space is probably different. The way that we show sample space with this letter capital S. So this is how we show sample space. Sample space can be discrete or it can be continuous. What is the difference between these two? Discrete sample space is when the outcomes in the sample space are countable. So countable outcomes. But continuous sample space is when the outcomes are not countable. So non-countable outcomes. Well, when you think about flipping a coin once, the number of outcomes are countable. 1, 2. The number of outcomes can be infinite, but countable. So that's a possibility. You have infinite countable outcomes, and that's a discrete sample space. But when the sample space is non-countable, just like, let's say, human height, right? The height of us humans is a continuous spectrum of numbers. Between each two numbers there are infinite numbers possible. That's why it's a continuous sample space. So that's the difference between discrete and continuous sample space. So as we said, flipping a coin, the sample space is heads and tails. And I want you to pause the video and think about the sample space of flipping a coin twice and throwing a die. For flipping a coin twice, there are 4 different outcomes. So the sample space contains those 4. Heads, 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 tails, tails, head, and tails, tails, right? So 4 different outcomes in that sample space. When you're throwing a die, what is the sample space there? It is 1, 2, 3, all the way to 6. 6 different outcomes in that sample space. Let's look at another example. This one is a little bit more difficult, and I want you to pause the video and work on this slide. So let's consider a container with one red, one blue, and one green marble, as you can see in this picture. And the random experiment here is selecting 2 marbles simultaneously. So basically, you put your hand in the container and you grab 2 marbles. What outcomes can happen? Well, you might grab these two, you might grab these two, and you might grab these two. That's all the three possible outcomes, right? So I'm going to write red, blue, I'll say green, red, and green, blue, right? The other experiment is selecting two marbles sequentially without replacement. Basically means that you put your hand in the container, you grab one marble, and then with the other hand you grab another marble. It's not at the same time, it's sequentially. And it's without replacement because you don't put back the first marble that you grab. So what is the sample space here? Well, what happens here is that the order matters. The order of marbles that you grab here matters. Basically, you can have blue-red, you can have red-green, and you can have blue-green. So you double the size of the sample space by just grabbing them sequentially. So I'm just going to write them down here. So there are 6 outcomes in that sample space. The last part is a different random experiment. Select one marble, put it back in the jar, and then select the second marble. With basically is with replacement. You put back the first marble that you grab. So what happens here, there are more outcomes that you create in this experiment. You have all these outcomes, plus you might grab the same marble again. So basically you can have red, red, you can have blue, blue, and you can have green, green, in addition to the outcomes that you have here. So I'm going to write them down here. So what happened here is we had order that mattered and also repetition. So you can see here that with the same container and the same marbles, we can define different random experiments because they have different sample spaces. In the next video, we're going to continue this and look at roulette wheel and continue the list of topics that we want to introduce.